All right, guys, welcome to day 2 of Mrs. Martin's videos. I feel like we need an intro, like a Mrs. Martin's math class intro. If anyone has a good opener, feel free to send that my way. It'd be kind of cool, since apparently we're starting a Mrs. Martin channel. But anyway, all kidding aside, we're starting our notes today. We're continuing on from where we left off. It's looking like we're going to be doing this online education for at least another month. So we're going to go ahead and continue with our material, and I have every confidence that you guys are going to do great with this. One thing that I do enjoy about these videos is you, as the viewer, can pause and rewind and do whatever it is you need to do to understand what's going on in the video. If you run into any questions, as I'll mention and remind you again of later, please post them in the discussion forum. I'm always going to post these video links in a discussion forum, and I would like for you to post that you've seen the video. That way I know that you are at least logged into Schoology and you found the discussion assignment and you hopefully clicked on those videos and watched them. I know they're kind of lengthy. It's like being in class, but do your best. And then if you have questions, that's a great place to post them. I'm hoping that you guys will be able to share those with each other. And if you have answers to people's questions, and you guys can feel free to reply and help each other out. And if no one knows the answer, then that's why I'm here. And I'm sure that me answering those questions not only helps you, but helps your classmates. So again, I really encourage you to post questions and wonderings in the discussion forum so we can figure those things out together, especially if I miss something in this video. I think it's really helpful. So whenever you ask questions, just please understand that you're helping everybody involved. So I think they're great. And thank you to those of you who are already asking questions, and please keep up the good work. So you guys have had about a week now to kind of ease into this online stuff, and now we're going to blaze ahead and continue with our math curriculum. And today I'm going to go ahead and start with my pretty glitter pencil. I'm going to call these notes, and these are notes on an intro to exponential functions. Okay, so to kind of recap, you guys have hopefully seen exponential functions already. They were one of our parent graphs back in Algebra 2. We saw them in the coronavirus video before we left school. And they look a little something like this, and they've got a bit of information that goes along with them. Okay, here is my glittery exponential function. Okay, it gets real flat over here on the left, starts to grow very rapidly on the right. It's the reason everybody's scared right now, because it's the way that the virus was growing last time we spoke and last time we saw that video. Exponential growth, things that are multiplying over and over again. So we're going to look at a few things about exponential functions. So we're going to look at a few components of exponential functions. So here's my function notation. I'm always going to start there. And exponential functions have like a standard form, okay? In ALEKS, they use the letters A and B. In your textbooks, they use the letter capital C and lowercase a. For the purpose of this video, I'm going to go ahead and stick with the letters that your textbook uses. That way, if you want another reference besides ALEKS program references, you can go ahead and look at your textbook. Hopefully you have it at home. So here's the capital C, and C has a few things. First of all, C does not equal 0. Okay, if C equals 0, and I'm multiplying it by the next component, which is A, then the whole thing would be gone, and you just have f of x equals 0, and that's a constant, so that's a horizontal line, and we don't need that. So C, for our purposes, cannot equal 0. It can be negative, it can be positive, it can be a fraction, it can be a whole number, but it cannot be 0. And we refer to C as the initial value, which is hopefully a term you guys are familiar with. It was the b in y equals mx plus b. You know, it was that place where you started. It's this point right here, C, our initial value. Okay, it's a place where we cross my y-axis. All right, and it's going to be really important. It gives us a lot of information. Now, A is multiplied by C eventually, and A has a few things that it can and cannot be. A's got to be greater than 0. Again, it can't be 0 because that would make that constant, which is y equals 0, and we don't need that. But earlier today in Zoom, if you didn't get a chance to join us, we noticed that when we made A negative, Desmos just deleted the whole function. It didn't understand what it meant for something to be to have a negative A value, and that's because A is considered by your book our growth factor. Okay, factor meaning multiplication. So the way some population is multiplying, and this could be increasing or decreasing. When we talk about populations growing or shrinking, for that matter, we don't talk about shrinking in terms of negative numbers. We talk about growing as in a population of rabbits doubling or tripling or multiplying by 10 each time. Or, for example, if we're trying to exterminate termites, perhaps their population will decrease by half or a fourth, right? So we never really talk about decreases using negative numbers. And so I think it's important for us to remember that A is going to be greater than 0. Okay, and I'm going to go ahead and put A in parentheses for us. This isn't in your book, but I think it's going to help us keep track of what needs to be multiplied first when we're working with these exponential functions. Okay, and of course, we can't forget the only thing that makes this function exponential is the x in the exponent of A. And again, that x is giving us a little bit of information too. It's telling us how many times I am multiplying the initial value by the growth factor. So how many times we multiply C by the growth factor. Okay, in word problems, which we'll see later on, that means things that are, you know, if my mouse population in a field is multiplying by 2, then that would mean my initial population of mice every month, for example, maybe it doubles. I mean, that would be a huge problem. That'd be a lot of mice. And normally we introduce some sort of predator into that model. I think we've spoken about this in class, but that's what X makes A do. It tells me how many months go by, how much time goes by, how many times are we going to actually multiply the initial value by the growth factor. Okay. For example, in our video before we left to try out this new online education, we talked about the growth factor for the coronavirus. I know you've heard a lot about it already, and you might be tired of hearing about the virus at this point, but COVID-19, when we spoke at the beginning of March, its growth factor was 1.15, which technically meant that the population was becoming infected at a rate of 15%. And I believe that growth factor that he was looking at was per day, which is a little scary. Hopefully at this point that growth factor has decreased a little bit because all of us are trying our best to stay home and wash our hands and stay healthy and drink lots of water and whatever other tips we've been given to try and stay safe. But at the time at the beginning of March, that was our growth factor, and that was how the population was increasing as far as who was getting infected, and that's why people were so scared. So again, hopefully that growth factor has gone down. I think it's worth looking up again and trying to make our own exponential model. But that's how growth factors are working. And as you can see, we actually have already gotten to see them in real life. Okay, so those are the basics of our exponential function and the form that our book uses. Let's go ahead and try some examples out together. I'm going to go ahead and make a table. And I think you guys kind of have an idea of how to make a table from a function, but I want to take this moment to try it out all together anyway. So I'm going to go ahead and write out an f of x, and I'm going to try and stay true to the colors that I've chosen. For my c value, I'll pick a 3, and then for my a value, I'll go ahead and double this population. Okay, and I'm going to make myself a small table here, x and y, and I'm going to fill in this table. This is actually one of your homework assignments, to fill in a table based off of a function you're given. And I want to make sure that we all understand how to plug in numbers and in what order we should be working on them with. I think that's the part where a lot of people get stuck. So I'm going to go ahead and do like your Alex homework and use those values for x. Okay, a lot of mathematicians want to see what's happening around the y-axis and around the origin. So that's where we pick. So I'm going to go ahead and do f of -2, and I'm just going to, I'm trying not to skip steps here. I'm going to plug this in to my x value. So if I carefully remember my exponent properties, I know that -2 makes my 2 drop down to the denominator. Okay, so that's why we went over exponents first at the beginning of this semester. So hopefully you remember those. That -2 makes me use a reciprocal, okay? And so then I'm going to work that out. I've got a 3 times 1/4, and now I've got 3/4 as my answer. I can go ahead and write that over here. Okay, and I'm going to go ahead and continue on quickly with f of -1. Okay, now I've got 3/2. Now I'm going to go ahead and skip ahead to do the rest of them. Okay, so I did all my math, so I can fill in my table, and there it is. And I want to point out a few components about this table. First of all, my initial value is right here. And how do I know it's my initial value? I mean, first of all, it's in blue on my function, right? 3. But really, if I didn't have that function, I know it's my initial value because x equals 0. And when x is 0, that means it's on the y-axis, and that's where my initial value is going to be. So that's really important to remember. It's something that we did a lot with linear functions, and it's something we're going to continue to do here with exponential functions. Now, how about the green 2, right? So it's given to us, but where do I see that in my table? Some of you pick it up right away because you just can see the pattern. You know, every time I go up, it's times 2, you know, times 2. Every time I go up in this table, it's times 2. But for example, that COVID-19 1.15, I'm not sure I would have seen 1.15 as the pattern in an XY table. So something that might be very important for us to notice and to make sure of is to use ratios by putting the second number or the later value over the first over the previous value. So for example, over here, I would put 12 over 6, and I'd simplify. I could do, and it's any consecutive pair, so 6 and 12. Now I'm going to do 3 and 6, so 6 over 3, that simplifies. Now again, I always do the later one divided by the prior one. Okay, 3 over 3 halves, that might be a little harder to see, but if I do the reciprocal, that ends up being 3 times 2/3, and that equals 2 again. So notice I keep getting these 2's. Sorry, let me stick with the color. I keep getting these 2's here, and that's how I know what my growth factor is. Okay, and so if later on we're working with a table and we're trying to figure out what the growth factor of a population is, we can do that based off of a table. Again, very similar to y equals mx plus b. It's just that now this is how our group is changing, no longer slope, now it's growth factor, and this is our initial value. That part works the same. Okay, so I'm going to take us over to Desmos so that we can look at a few of these graphs using Desmos, just for the purposes of understanding about asymptotes and looking at what those look like. So I'm going to start out with the real basic function, starting out with my function notation. And for C, our initial value, I'm just going to say 1. Now, I don't have to type 1. When I'm actually writing out the functions, I can leave it out as a matter of fact, but I want it there for today because I want us to be able to see the parts, the components of these exponential functions. So I'm going to leave 1 in there for now. Now I'm going to put my 2 to the x power, whoops, over here in parentheses. Okay, so there it is, my real basic exponential function. I'm going to zoom in a bit here so we can really see what's going on. Here's my initial value, which we just discussed. It's at 0, 1. Okay, and my function is doubling. As I move up along here, I've got 1, 2. I keep moving and I see if I can get here, 2, 4. Well, you get the idea. There it is. And so on and so forth. I can keep moving along there. Now, I had a question during our Zoom meeting, and I asked students, will my function ever be negative? So I see my function here, and I want to see if it ever becomes 0, right? Because if I look over here to the left, I notice that this exponential function, I mean, it kind of starts to look like it's touching the x-axis, but if I zoom in, and I try to see what's going on when I get close to this x-axis, I start to notice that even though I'm pretty close, it's still got this sort of gap. So I'm not really touching this x-axis, meaning y equals 0. And maybe if I go really far to the left, that kind of looks like it's touching. But again, I zoom in a little bit, and it's barely hovering above. So that made us start to question, will my function ever be 0? Will it ever pass 0 and become negative? And we looked at it this way. Let's look at the function. So right now I've got 2 to the x power. Oh yeah, okay, so 2 to the x power. So what are some things that I can plug in to x, right? So if you think about it, I can plug in positive numbers. I can plug in negative numbers. I can plug in fractions, decimals being the same thing, and I can plug in 0. So what happens when I plug all of those things in? So let's do a few examples, right? So what happens if I plug in, for example, my positive numbers? Okay, when I plug in positive numbers, for example, let's say I plug in 2 to the 1, that gives me a 2. I plug in 2 to the 3, that gives me 2 times 2 is 4, times 2 is 8. If I plug in 2 to the 100, it's going to give me some crazy number because that's how exponentials just work. I'm taking out my calculator here, and I'm doing 2 to the 100 power, and that gives me 1.268 times 10 to the 30. I'm not going to write that out. That's a humongous number. But regardless, these are positive numbers. They're large values of y. Okay, which again, think about the graph of this thing, right? It crosses at 1 and it doubles every time. So it kind of makes sense that when I get further out into my y-axis, I'm sorry, my positive x-axis, I'm going to get these huge positive values of y. Okay, well that was kind of obvious, I suppose. So let's try negative numbers. Okay, and again, these are negative values of x. So now I'm looking over here on this side. So negative values of x, let's see what happens with those. So I'll try 2 to the negative 1. That's really only 1/2. Remember, negative exponents don't turn my numbers negative. Okay, so 1/2, still a positive number. Let's try 2 to the negative 3. Well, that just makes it 1/8, which again, positive number. It's getting pretty close to 0, but it's not necessarily 0 itself. And it doesn't bring my function below the x-axis to give me negative values of y either. 2 to the negative 100, hopefully you guessed it. It's 1/1.268 times 10 to the 30, okay, which again is a number terribly close to 0. So my negative exponents didn't do the trick either. Negative values of x did not produce negative values of y. I can continue on and try those fractions for the rebels out there that thought about plugging in fractions, okay? If I do, sorry about that, if I do 2 to the 1/2, which is a pretty typical fraction, that's just the square root of 2. Still a positive value for y. If I do 2 to the 1/4, that's the 4th root of 2. Positive value of y. If I do 2 to the 5/11ths, that's the 11th root of 2 to the 5th power. So again, we're faced with positive values of y. And finally, plugging in 0, we all know what happens when we plug in 0 to a number as its exponent, right? Any number to the 0 power is 1. There's not much more we can do with that. So ultimately, this was all just to say that this particular exponential function will never be below 0. And as a matter of fact, it doesn't look like it'll ever be 0 itself either. It's just by its nature. So if I go back to my Desmos here, and I zoom out so I can look back at the function, this function has a horizontal asymptote. Remember, this was all so we could just discuss asymptotes. And this asymptote is right here on the x-axis, and I can call this asymptote y equals 0. Okay, and that's going to be the case. We tested this out on Zoom when we were on Zoom earlier this morning, and we were seeing what would happen if we made that negative. It flipped it down a reflection across the x-axis. We checked to see what would happen if I made the x and the exponent negative. it made a reflection across the y-axis. It started to look a lot like our transformations, which is what it should be doing. So then we ran into the problem of, well, can I ever make the asymptote move? I mean, right now, my asymptote is y equals 0. Now, what will it take for me to move this function down? And in our discussion, we were able to discover that to move this function down, we would need a vertical translation. And you guys know how to do vertical translations. That would just mean I subtract a number here at the end of my function. And so my horizontal asymptote becomes exactly what that vertical translation is. I'll move the whole thing down. Okay, so if I wanted to move it down to -10, I would also move this horizontal asymptote to -10. If I wanted to move it up to +3, my horizontal asymptote would also move up to +3. So it's your translation that would be moving your asymptote. Otherwise, any exponential function without a translation would just have an asymptote of y equals 0. Okay, and that pretty much takes care of our lecture for today, this intro to exponential functions. On Schoology, let me scroll over here to Schoology. If you scroll down, I will be posting a discussion right down here, just like the Watch Mrs. Martin's 320 video. You'll have a new 324 video. And again, you can post questions, you can post responses, let me know you watched the video. If you have any questions or comments, you can leave them there. If you have any suggestions, I would love them. You can leave them there in the discussion as well. And please make sure you get this homework number 7 done. That's right down here. You sign into Alex, which I will go over right now.